Alright, we're going to start with several basic algebra problems here and demonstrate the method of manipulating terms around so that we can eventually isolate the variable. And what we want to do is isolate the variable, get it on one side by itself, and once we have done that, then we will have solved for the value of the variable. In this case here, we have 7 is equal to y minus 2. Okay, so we have a minus 2 on this side. What we do to try to isolate the variable is we do the opposite of what someone else has done to the variable. In this case, we've got the variable, someone is subtracting minus 2, they've put a minus 2 in here. We do the opposite, so we'll come along and with the minus 2, we'll place a plus 2 in there, which is the opposite of the minus 2. So this is the new value placed in. Now, when we do it on the one side of the equation, we must also do it on the other side of the equation. So we put a plus 2 over on this side. Now, when we resolve those two things, the 7 and the 2 become a 9, and on this side, the minus 2 and the plus 2 wash each other out, so you're left with a y. So you now have the y, or the variable, on one side, isolated by itself. We know what the value is. Here's the answer in blue. Y is equal to 9. Moving on up to the next problem, we look at problem 7, and that problem indicates that we have an equation which says s minus 7 is equal to 15. Now, in this case, the variable has been named s. We could name it anything we want, a q or p or whatever, but someone has named the variable here s. And so, in addition, someone has placed a minus 7 in here. So we'll do the opposite in order to isolate our variable. So we now have s minus 7. We do the opposite of the minus 7. We put a plus 7 in here. On the other side, we must do the same thing. Put a plus 7 in here. And what happens here is when we put the 15 and the plus 7 together, we get a 22. Over on the left side, the minus 7 and the plus 7 washes out. We're left with s by itself. And so we now have s, the variable, isolated on one side by itself. Its value we find is equal to 22. Going on to the next problem. Moving on down to problem 15. We have an equation here with minus 12 on the one side equal to x plus 4 on the other side. In this case, again, our variable here is called x, and someone has put a plus 4 with it. We need to get that out of there. We'll do the opposite. So we put a minus 4 to go with the plus 4. We have to put the minus 4 on the other side of the equation also, because remember, what we do on one side, we have to do on the other side. And so back to the right-hand side, the plus 4 and the minus 4 go together to cancel each other out or wash out, and we're left with the x by itself. Over on the left-hand side, we put the minus 12 together with the minus 4, gives us a total of minus 16, and so x is equal to minus 16. Now, when we have the variable on the right-hand side as shown, we can just swap that around. We can place the x on the left side and the minus 16 on the right side, which is conventional algebraic notation where we have the isolated variable on the right-hand side. Again, that variable x is equal to the value of 16. So that's our solution. End of this problem set.